welcome. So in this lecture, I'm going to go through, so in this lecture, in the next two lectures, I'm going to go through some examples of integration by parts. Some of them are kind of special tricks. And that's just kind of extra practice. So the first one that we are going to do, so the one we're going to do in this lecture is going to be x squared e to the x. And so we're going to need to perform integration by parts twice. So let's go ahead and do this. So I want to highlight, the first thing we want to do is to figure out our u and our dv. So this is going to be our u. Okay, so we're going to have that u equals x squared, and so then we also have that du equals, so we need to take the derivative of this, so we get 2x, and then we write dx. And then over here, we're going to have e to the x dx is going to be our dv. Now, the antiderivative of e to the x is just e to the x, so that we get v also equals e to the x. And this is where we're going to need to be. So we're going to be very careful with parentheses. But we can, as long as we're being careful with parentheses, we can just kind of go ahead, right? So what is this going to equal? Well, we're going to get u times v. So we take our x squared. And then we take our e to the x. And now we need to subtract off. So minus the integral of, so now we need our v du, so we're just going to get 2x e to the x dx. Now, in a normal circumstance, we would be done here, but we still are not able to integrate this. So we might get a little nervous, except for the fact that we see that, oh, this is definitely the kind of thing that integration by parts is excellent for, because the x will basically drop out with integration by parts. So I'm first going to write this. I'm going to pull out the 2 just to make it a little simpler. So I have 2x squared e to the x minus 2 times the integral of x e to the x dx. And now we're going to do integration by parts a second time to try to figure out this. But we're going to be very careful with our parentheses. That's really the key with these kinds of problems. So now our u is going to equal x. And our dv is going to equal e to the x dx. So here we go. So u equals x. Right? Which then gives us a du. So the derivative of x is just 1. So I take 1 times dx. And then for my dv, it's going to equal e to the x dx. Again, the antiderivative of e to the x is e to the x. So I just get that v equals e to the x. Great. So now I'm going to very, very carefully do this. I recommend doing this here inside of here, but with parentheses. I'm a big fan of parentheses. You probably already noticed. So I keep my x squared e to the x, because what I'm integrating is this. That's the only thing that's going to change. So I'm just going to put for myself some big parentheses so that whatever I'm getting from the integral there goes inside of here. The 2 is pulled out, right? Okay, so now we do what we typically do. So we take u times v, so I get x times e to the x. And then I'm going to subtract off the integral of, so now I need to do the integral of v du. So I have e to the x dx. And then this is something that's so much easier to do, right? Because now this is just, the antiderivative of e to the x is just e to the x. So this is going to be so much easier to do now. So I'm just going to get x squared e to the x minus 2 times, and then I have x e to the x minus, and then I just have whatever this antiderivative is, which is just e to the x. And I have a plus c. I waited to put the plus c until I'd done all of my integration, because we know we can just kind of group constants because they're like closed under multiplication by constants and addition of constants. Okay. So now I can just kind of write this all out. So I'm going to get this is going to equal x squared times e to the x minus, so we distribute the 2 there and get 2x e to the x. We distribute that and get plus because it's minus minus, and then we get e to the x plus c. And now we might want to kind of pull out our e to the x. So we're going to get that this is going to equal e to the x times x squared minus 2x plus 1. Oops, I missed a 2. There's the 2. Plus 2 plus c. And we're done. So really, this is very straightforward integration by parts. We're just going to do it twice. That's the only thing. And to keep track of what we're doing, as I said before, I'm a big fan of parentheses, so that you can kind of keep track of what sits where. So kind of looking at this, we do the first integration by parts. This is our u. We know that the power is going to go down, which tells us this is a good u. And then e to the x dx doesn't become any more complicated. So we take the derivative of u, which is x squared, to get 2x, and then we just multiply that by dx to get du. And then for dv, we just want to take the antiderivative of e to the x, and that's just e to the x. So we just apply our formula, and we get x squared e to the x minus the integral of 2x e to the x dx. And now we look at this integral, and it's actually a good integral for integration by parts. We otherwise wouldn't know how to compute it. So then we just go ahead and we apply integration by parts again after I pull out the 2, just so that I've isolated that integral. And notice that I keep the entire integral inside of parentheses here so I don't get confused when I'm plugging things back in as to my work. It's really important to keep your work neat so that you don't get confused. So now we do this one. So again, x, the power goes down, so that's a good candidate for u. I take the derivative of x, I get 1. So du equals 1 times dx, or just dx. And then for e to the x dx, when I take the antiderivative, I get e to the x. And then, of course, I drop the dx there. So this is, again, uv minus the integral of v du, just from here. But I did it inside the parentheses so I didn't get confused. As I mentioned before, I waited to put my constant on the end, just because what else would have happened would have just been that my constant would have ended up over here. And it could have just combined the two constants. Okay, and then at this stage, it's just a matter of distributing. So this is all I did here, minus 2 times this, and then minus 2 times this, and that gave me a plus 2 e to the x, and then I got the plus c, and I pulled out the e to the x, and then I was done. Okay, so this was just an example of, as long as you kind of stayed calm and kept your work very neat, this actually is no more difficult than doing integration by parts once. Okay, so I hope that's helpful, and I will see you in the next lecture.